Okay, and let's give everybody a minute to join. How many people do we have coming? We have one. Okay, people are starting to show up. Hello, everyone. We're going to give everybody a minute or two to join before we are going to go ahead and get started. See a lot of new names, which is exciting. Just for fun, before we have everybody join, can you post where you're calling in from, location wise, in the webinar chat? I'm calling in from Berkeley today. Okay, let's give everybody one more minute and then we're gonna go ahead and get started. Okay, I think we have people still joining in, but I want to be punctual and get going. So welcome everyone to our lunch and learn on GenAI and the future of accounting. I'm the host today. Andrew, I'm the co-founder and CEO of a company called Klarity. We're a San Francisco-based applied AI company that built a system that allows companies to automate their accounting and compliance workflows instead of offshoring them. We've built this company over the last 7 years or so, and we're serving some of the largest companies in the world, including the likes of Google, OpenAI, CrowdStrike, DoorDash, Zoom, and many others. And Zoom is enabling the session today. What we're going to cover today is kind of two-part lunch and learn. The first part is a little bit more of a general introduction into AI and how we're thinking about it. Some of it is just from a technology perspective, but a lot of it is about what are the biggest opportunities for applied AI. And then, and I'm getting the chat is disabled for folks. Ali, can you please try to see if we can enable chat? I think we're going to need that for Q&A as well. Thank you, Alexandra, for flagging this. Okay, and then in the second part, we're going to actually focus on specific workflows that can be automated for finance and accounting. I like to make these sessions pretty interactive. So if you have any questions at any given point, feel free to drop it in the Q&A bucket, and I will make sure to answer it as we go along. And then of course we're going to dedicate some time towards the end of the webinar to answer any other questions that might come up. All right, so we're hearing about AI all day, every day. And the reason why we're hearing about AI all day, every day is that it's the fastest adopted technology ever in the history. So even this chart on the right side is 2 months old now. But at that point, we basically had almost 80 million monthly active users of an AI tool, whether it's Google Bard or ChatGPT or Character.ai or Stable Diffusion in the United States alone, which is about 3 times as many as we had with smartphones 1 year in. I think there's one very interesting trend that I'm seeing that's very similar that to what we saw when smartphones really started hitting the market, and that is in every group of roughly 10 people, you will have one person who's a power user of AI, and that feels very similar to what we've seen 1 or 2 years in after smartphones were introduced, where you had this power user, and the power user is telling everybody how they're using it and what is the value that they're getting out of it. And so from a pattern recognition perspective, a lot of technologies that ultimately end up being a kind of true major technology waves follow that same pattern. And I think we were seeing exactly the same trend with GenAI. So that's what we're seeing here. I like to joke that we started an AI company 6 or 7 years too early, but we spent a lot of time thinking about like what is the frontier, what is the biggest opportunity that Gen AI is actually bringing, or AI in general is actually bringing. And if there's nothing else that like you'll be interested in today, I think the biggest idea is that not to think about Gen AI as like another piece of software, or I have this little feature in whatever technology or whatever piece of technology that I'm using today that's helping me to do something. I think the biggest thing with AI is that it's a labor arbitrage opportunity with cost that's decreasing over time. What we mean by that is suddenly everybody, irrespective of seniority on every single team, has the ability to have one or multiple assistants that help them do something. Our customer support team has an assistant that helps to answer draft responses to support tickets. Our product allows companies to generate an accounting memo within a couple of seconds or tens of seconds instead of half a day. We see our engineering team is generating production code using GitHub Copilot much faster. And so every single person around the table at every single company suddenly now has the ability to have multiple of different assistants helping them being 10x more productive or 100x more productive in certain cases than they were able to do before. And so I think the challenge that I would bring to the table is not to focus on one kind of a small thing or one small thing that AI enables in the existing tech stack, but it's like, what is the next frontier of manual work that AI can actually automate for me? This is how it, and so from like an accounting perspective, right? So where does this fall in the enterprise architecture that companies are working with? So most companies are working with this like source of truth technology stack, which is today is typically the ERP and a kind of a data lake like Snowflake and so on, where there may be some production grade data. But really, more and more what we're seeing is that companies are using ERPs as kind of a GL layer. And then they have an application layer. Those are vertical applications serving specific teams that sit on top of the ERP, and they're kind of the best in breed, right? So on the revenue side, we typically see CPQ, CLM, billing system, and then revenue subledger. On the vendor side, we typically see some kind of a vendor subledger, whether it's Coupa or Zip or something like that. We're seeing some kind of like very unique subledgers, like for ASC 842, like lease accounting, and so on. But all these kind of best of breed applications that all sit on top of that ERP. And then where, in our view, AI has the biggest potential to transform things, especially for accounting, is if you look at all of that manual work that happens on top of those systems, whether it's data reconciliation or data matching, right? A very popular use case that we see is order management, which is basically, I have a bunch of data in my CPQ, I have signed something with a customer, I want to match that or reconcile that and basically say, is the data that I have in my CPQ correct? Right, or ASC 606 compliance. I need to review a certain set of documents and identify if I have any non-standard terms, and then document those terms and create an accounting memo. And so all of that like manual work that needs to happen on top of those systems is something that AI can actually help with, or for the most part. What's really interesting about GenAI specifically is that it can help both with these like highly repetitive workflows like 606 compliance or invoice processing or two-way, three-way match on the AP side. So it can help with that, but it can also help with like unique and one-offs. I need to respond to this audit request or email request, right? Or I need to do a specific research on where does IFRS 15 differ from ASC 606, or whatever that is. And that's a pretty unique application. In terms of the kind of like what it does to a single company what it does to a company on a company-wide level. So I think there are kind of like three biggest notions or three biggest things that it enables, and that need to be considered for every finance and accounting team, because it just changes the landscape so much. So I think the first and the biggest thing, and that we've seen internally as well across the board, is that GenAI and GenAI tooling turns a lot of variable cost into fixed cost, or something that looks almost like a fixed cost, especially for like very linearly scaling or exponentially scaling variable costs. AI is turning those into fixed or very, 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 very slowly, very slowly rising linear cost. What I mean by that is specifically, so for example, if you are processing, let's say, 10 invoices a day or 100 invoices a day, for every 100 invoices, you might need a new AP clerk, or for every contract or order processed, you need or for every 10, you need another person, or on the engineering side, for every 1,000 lines of code that you write per week, you need another engineer. And so there are all these kinds of like very linearly scaling costs in our business, and AI is turning a lot of these into fixed. So what we've done, we've automated a lot of, for example, cold outreach on the BDR side at Klarity. We're using GitHub Copilot to write more code more efficiently. We're of course using Klarity to automate our own internal finance and accounting processes, and a lot of it is basically because the incremental cost of processing more transactions is much lower than if you think about it. And so I think that's the biggest thing from a financial makeup of every single company that we're going to see over the next couple of years is kind of a decrease of which costs are variable versus which costs are fixed. The second thing that we started seeing internally as well is it requires rethink on how we allocate capital between CapEx and OpEx. So the number one thing that we're seeing is that implementing a lot of these tools or a lot of automation across the board has higher CapEx demands than just adding another person, right, to do more of X. But one of the things that we're seeing is that then the payoff, especially in like the 12 to 18 months from now, is pretty drastic, because it's this incremental cost of OpEx of like adding another person is always lower than the CapEx to put automation in place. But then we're seeing these results where like once the automation is in place and everybody at a certain team with a certain workflow is able to take advantage of it, the throughput is raising exponentially. And so I think that's kind of like the second thing from a finance perspective to really think through. And then finally, the really interesting thing is like we're starting to move away from like a monthly close or having to do like a lot of reporting or analytics only after books are closed, because the reporting and the analysis is so expensive, because it's a lot of people doing a lot of work, from like writing scripts and building dashboards and charts and so on. Because that's so expensive, we want to wait for the monthly close today. But with real-time reporting capabilities and with the ability of large language models to write code on the fly, well, you actually don't need that. You can just report on data that might be imperfect or it might be before closed, but because the cost of that report is basically zero or close to zero, because the code is written automatically, and all these reports are generated automatically, it suddenly enables you to be much more nimble with reporting and making business decisions in real time, as opposed to waiting for the month close, and then the reporting that follows. And so those are kind of like the biggest three things that we're seeing that AI is bringing to the table from a financial and accounting perspective. And so what is the AI that's actually relevant for in finance and accounting? So there are really two key pieces of technology that have impact directly on our workflows. And that's LLMs, large language models. That's the stuff that powers ChatGPT, for example, or Google Bard, and computer vision models. And one of the things to always keep in mind is the nomenclature, the name GenAI is actually fairly misleading because it's implying that it can only generate new things. But it can also equally well understand existing artifacts. So it's both generating new artifacts, GenAI, generative AI, but also understanding existing artifacts. What I mean by that, again, is you can give it an invoice and say, hey, what's inside this invoice? Or you can give it a chart and say, interpret this chart for me, right, which is a visual element. And so the ability to both read and understand, as well as generate new things, is really like when it comes where it comes into its own. In terms of large language models, kind of the way they work is pretty straightforward. Conceptually, of course, like implementing this, actually getting it up and running is a tough challenge. But conceptually, the way large language models work is they are computing the most likely word that follows the previous word. What is the most likely word following the previous word? And so in this case, what we're doing is we're counting the probability of distribution over a sequence of words. Right. So if I say I will take the dog for A, and I let, in this case, ChatGPT to finish the sentence, it finishes it with the word walk at 85% confidence. The reason why this works is because it has this statistical representation of what's happening in the real world by basically being trained on all of the internet's data. And so there's a lot of people on the internet talking about taking their dogs for a walk. And so that's kind of how that works. If I give a different context, like I like running, well, then, it has seen a lot of examples of people who say that they like running. They're talking about going for runs rather than walks or, going swimming. In the business context, of course, it's like we're seeing much more things like I will terminate for, what's the reason? Well, convenience. Convenience is the most likely outcome in this case, without any further context. And so large language models work in this way. And so where does all of this follow, right? So because we talk a lot about, we constantly keep reading about large language models, we're reading about computer vision models, we're talking about applied AI, and kind of like, what does the industrial landscape look like? And so the way we look at the landscape is really it's only like it's a pyramid with three buckets. The things that we read about the most are what we call platform or foundation models. And so those are the GPTs from OpenAI, those are the Claudes from Anthropic, and many other models. We're reading about Llama from Meta, and so on. And so that's the actual machine learning model itself. But even with the really popular applications like ChatGPT or Google Bard, there's actually a lot of product built on top of that model itself. So you're not interacting directly with the model. This is really like built for either the product team or the IT team that's working with it. Then there's this other layer that we call ops and ML ops. And those are tools that help you train models, fine-tune machine learning models, deploy those models, monitor their performance, do all kinds of different things. And again, this is still intended for product teams and for IT. And then finally, you have the layer of enterprise applications, right? And that's us for accounting and compliance teams. It's Jasper and Ada for sales and marketing teams. It's Harvey for legal teams. It's a lot of very different kind of teams across the board. But that's the actual productization of AI. So, and here are some of the logistics of deploying Gen AI. So there are really 4 key considerations today. The good news is that this slide used to be 5 considerations until about a month ago, but now it's, or maybe 2 months ago now. Now it's 4, and I would argue that in about a year it's going to be 3, 3 only. So a lot of the logistics that we're seeing today and the challenges as like being fairly early in the life cycle of this technology are being solved actively on a daily basis. But there are really 4 key things to think about today. So number 1 is hallucinations. I'm sure that a lot of you have read about hallucinations, but basically hallucination is that the output of the model is incorrect. Typically factually incorrect, or kind of like from a process perspective, incorrect. And the reason why that happens is because, like we discussed before, it's a statistical model. And so and the reason why it feels magical is also because it's statistical, right? Because the statistical representation from the model is very much aligned with our understanding of the real world, right? So the people who talk about running go for runs and so on. That's why it feels so magical, but doesn't actually have like conceptual understanding of any of these concepts. And so hallucination occurs when the model basically gives you an incorrect answer to something. And the good news about this is that's decreasing as models are getting better. Then the number of hallucinations are decreasing massively. So that's number 1, but it's kind of inherent to the technology. So we're always going to be seeing hallucinations, or for the most part. But then the other part is there's a way to deal with them. So on a product basis, if you're dealing with a specific workflow, and when you actually productize the model, you can have a product solution to eliminating hallucinations. So for example, what we do is we have something called novelty score, which is every single time we see a new piece of a document that we've never seen before, and we don't have enough confidence to understand what's inside, we can flag it to a human. And so we can avoid hallucinations from that perspective. What we see a lot of customers doing, for example, if they're using GPT or Bard to generate something internally, then they have some kind of a manual control around, 1 person or 2 people need to review this and sign off on that. So those are the types of things that we see there. Data privacy and data security. So these go hand in hand, but they're vastly different. And I think they're kind of getting conflated a lot right now. And so data security, I actually argue that there's not much, if anything, really new compared to any other piece of cloud software, any other piece of SaaS. Data security is about where does your data go? How is it protected? Is it stored? Is it encrypted? How long is it retained somewhere? But it's like using any other kind of a cloud infrastructure service in the world. And we already have, the set of questions that we need to ask and the set of certifications that we need to understand. So from a data security standpoint, I would argue that there's not much new, if anything. Where a lot of the new items and new considerations lie is data privacy. And so that's about what can happen with your data, who owns your data, who owns different permutations of data, what will you permit your vendor to do with the data, and so on. So those are things like, can your vendor train a new machine learning model with your data? Okay, if yes, then who owns the output of that machine learning model? Who owns the machine learning model itself? Can the vendor train the machine learning model with data from multiple different customers? And all of these things. We have a very strict stance that we don't use customer data to train anything, but some vendors don't. And so that's a really important consideration. Second consideration in the data privacy kind of angle is are there kind of augmentation techniques that you will allow your vendor to perform? So things like fine-tuning a model with your data. So taking an existing machine learning model and basically saying, hey, I'm going to give you a lot of examples of a specific type of data. Maybe it's a lot of my invoices or a lot of my order forms, a lot of my POs. And try to adapt yourself that you're really good at reading these. The same way you might have somebody on your team who, if they spend 5 years reading your order forms, and they're like 10x faster than everybody else, this is like kind of doing the same thing, just having the model to be kind of overfit for a very specific use case. And so data privacy is this kind of like a fairly murky and fairly like amorphous area, and there are no set standards just yet. And so I think it's always like really important to understand what does your vendor intend to do with your data? Do they have all the security certifications, all their SOC 2s, Type 2, SOC 1 Type 2s as well, if applicable? And do they have the same relationships with their vendors, right? So for example, we have DPAs with every single AI vendor like Microsoft or OpenAI or Google that we're using. And we have data protection agreements, and we know exactly what's going on at any given point. And then of course is like, what is that sub-vendor's reputation as well, and are they trustworthy? So that's data privacy. And then finally, runtime and performance. And so I think this is the last but very important consideration right now for certain types of use cases. So for those of you who have used BARD or GPT, and you know that a lot of the times the words like appear like one after the other, right? Because the model is basically predicting the next word in real time. Part of the reason why it's kind of slow sometimes is building that physical infrastructure, right? It's getting NVIDIA H100s and H200s and A100s and A200s deployed in data centers, because there's just so much demand for AI that the infrastructure is only catching up right now. And so this matters only in certain use cases, right? For some use cases, if you're like reviewing a contract for ASC 606, it doesn't matter if it takes a minute or 5 minutes to process. But for certain types of use cases, especially around fintech, if you need to get an answer in 100 milliseconds, that's either pretty much impossible today, or it's so expensive that it makes that use case not viable necessarily. Our expectation is that we're going to start seeing this go away in about 12 to 18 months. And it's going to be incremental for a while, and then at some point, like this will just completely drop off, and it's not going to be an issue at all. But it's a thing to consider today. So that was kind of the general introduction and general introduction and kind of how to think about AI. And here's what we think is the future of accounting, and kind of broadly future of business. So I think AI, and kind of this is tying it into the original idea about having everybody being very scalable with a bunch of different assistants effectively. I think what we're going to see now is this rise of exponential organization. And so what I have here, and I'm sure some of you have already seen the slide, this is one of my favorite slides, is AT&T in 1982 was the world's most valuable company by market cap, and it had 500,000 employees, 500,000 people to support the largest market cap in the world. In 2016, it was Google with 60,000 employees. So about 10x improvement, or at least an order of magnitude improvement. Our core thesis about everything that we're seeing with AI is that the world's next most valuable company is going to be able to do it with 5,000 employees, or maybe it's going to be 6,000 or 7,000, but another order of magnitude jump. And the reason for that is AI is just making everybody so much more productive. I think on a macro level, I think this is really exciting, because this is basically giving us the next generation of growth in our economy, right? If you need 5,000 people instead of 50,000 people to support the same volume of revenue, then we can build many more companies. We can increase commerce. We can increase, we can significantly increase the size of our economy. And so from that perspective, that's the key reason why we're so excited about this. And then how do you do it, right? It's like, how do you actually go about, and like, how do I build an accounting team, or how do I build a finance team that's thinking this way and being 10x more productive than otherwise? So we bucket everything into two kind of sets of use cases, or two categories of use cases. We have what we call personal assistant use cases, and then high repetition use cases. And I need to give credit to Sume from OpenAI, who's the controller there, to come up with this framework. But basically, what we're looking at is there's certain types of, I don't even want to say workflow, because these are unique tasks that somebody needs to get done, whether it's reconciling two unique, very unique situation, right? I'm not running this reconciliation every month or every week or every day. This is like a one-off reconciliation, or writing a one-off accounting memo, or doing whatever, some kind of writing a one-off script to do some kind of a database query. And so all these kind of like one-offs or some things that are so infrequent that don't make sense to be productized on an ongoing basis. And so for those use cases, ChatGPT and Google Bard are the best products to use, at least today. And the three key considerations there are that you need something that's very flexible, because you can't, you don't necessarily know what the use case might be. Second thing is putting manual controls around it. The most common manual control that we see is if you generate something that will be read by somebody else or auditors, you need to review it. And oftentimes we see kind of like two levels of review, like you and somebody else needs to sign off on it. You need to do the factual checking. And that's basically to avoid any problems with hallucinations. And then finally, the biggest kind of consideration here is in InfoSec, at least today. And the biggest problem there is, like, since it's not like something that it's easily to scope, because those are a lot of like unique one-off use cases in the future. It's kind of hard to predict what information needs to be used or uploaded into the tool that you're using. And so that's one of the things that we're seeing as like one of the key limitations today. On the other side, there are these high repetition use cases where and typically for accounting teams, it's something relating to transactional work, either on the revenue side or on the vendor side or technical accounting side. And here the use case is something where actually rigidity is required, right? There's some kind of a process description or some kind of a checklist or some kind of another systematized way of doing the same thing again and again, right? And we all know that it's like even good surprises are bad in accounting, right? Because you always want to have a repeatable process. You want to have, for a certain set of inputs, you want to have a certain set of outputs. And so those are the types of use cases that Klarity is uniquely built for. It's like high repetition use cases, order management, ASC 606 compliance, ASC 842 compliance, purchase commitment disclosures, and in AP, invoice processing, and those types of things where every single input should result in the same set of or predictable outputs. Controls can be automated in this situation. Because you can actually, if you're looking at rigidity as something you want to achieve in the process, then you can put automated controls around it, right? You can say, hey, the system extracts these 15 things out of an invoice, and then it matches it against this data in Coupa and says if it's matched or mismatched. And then you need to test the population, basically say, yes, it's behaving that way. And so you can automate your controls around a lot of these processes. And then the other advantage of this is that it's you kind of know what information or documents or whatever or systems system data needs to be shared because it's part of a process, right? So, it's like, hey, I need to have Salesforce data here. I need to have order forms here. I need to have whatever here. But it's very much something that can be predicted. And so InfoSec, your CISO can sign off on it more easily because they kind of know what the state of data is. So that's in terms of identifying these two sets of use cases. In terms of identifying kind of the second ones, right? So what are the high volume use cases? So the way we go about this is like we always encourage, we use this framework internally as well, across the board, not just for finance and accounting. And we always encourage everybody to identify what we call schleps, like the type of work that people don't enjoy doing. And so we always start there. So identify schleps, identify the highly repetitive work that you're not enjoying, you're not necessarily providing a lot of value. So identify schleps, and then quantify the value prop. If I automate this, what am I going to get out of it? Is it going to be, am I going to save money because I don't have to hire 10 more analysts? Am I going to get better accuracy, right? If it's something that somebody doesn't enjoy doing, have to be doing, the chances are that it's not going to be as accurate as I need it to be. Or do I need this processed in real time or much faster than I'm today? Like, oh, if I have this transaction processed in minutes instead of days or hours, well, is there something else that it can enable me to do, right? So like matching quotes and purchase orders received from the customer. Well, if I alert them on a wrongly issued PO the minute they issue it or 5 minutes later, it's much easier to fix that and get that going than if I let them know in 2 days or 2 months. And so kind of identifying the problem, identifying the repeatability, especially if there's a team of analysts doing that work, and then quantifying the value proposition. Then we always build a BRD, fairly straightforward practice. There's nothing really unique about AI, just of how do we go about it. But then the really unique thing is, and this is probably the most important point here, you always need to run a proof of concept with whatever tool you're choosing for that specific use case. And the reason for that is AI is very powerful, but it's not almighty. And you don't know if the data set that you're going to be using, if it's possible to automate something if you don't try it before. There's just no way of knowing. And there's no way of knowing for AI companies as well. We, for example, when we're working with our customers, we require a POC. We require a POC for the customer, but also for us to be able to confirm that something is automatable, because there could be all these potential unpredictable things that you will not know until you try on the data set that's relevant for that use case. And so POC. If there's one takeaway from the slide, that's the one takeaway is POC. Then figure out how to have that solution airtight. And so kind of that goes back to again the potential for hallucinations, right? So does the product have a solution for hallucinations that makes it airtight, that makes it predictable? You always know what the result is. Versus if it's kind of a more of a personal assistant use case, then you definitely want to focus on figuring out, can I have some manual controls around it? And then the last step really is, do I want to run this specific thing as an autopilot or copilot? Autopilot means it runs on its own, and I'm getting the results of it. Maybe I'm doing some spot checking, but really, like primarily, it's running on its own. Versus copilot means it's helping me be more effective, or anybody on my team be more effective. But it's not necessarily doing this without me knowing. An example would be in Klarity is like writing an ASC 606 accounting memo, right? It's like you need to ask the system to do it for you. The system does it, and then you check it. That's an example of a copilot workflow. Versus an autopilot workflow is you can set up Klarity to order management, basically looking at, hey, I have this data in Salesforce, I have this data in my signed order, matching that. If everything matches, nobody needs to have a look at it. If it's mismatched, then it gets flagged to a human for resolution. So that's an example of an autopilot. That's an example of an autopilot workflow. And then finally, these are the use cases that we see the most. And of course, these are Klarity use cases as well. So on the revenue accounting side, we see a lot of quote to cash use cases as well, order management, ASC 606 assurance, kind of draft invoice validations against the signed order, matching quotes and POs, right? So especially if you have a channel and you're getting a lot of POs from your partners, and then matching them against the issued quotes is really important. Contract integrity reviews, kind of like final checks before something is signed. That's especially for large companies. That's a very important process. On the technical accounting side, we see a lot of commitment and contingency footnote tiles, so like purchase commitment disclosures. So what the system can do there is like, can take all of your vendor data, extract the start dates and dates, how much are you paying, and basically figure out which spend is committed versus which spend is contingent, and what is a gray zone, what is a gray area, and flag it to a human to consider that. And then it can actually export the data in the 10Q format. ASC 842 assurance, lease accounting, extracting data from leases and computing all kinds of things. PO accruals on the procurement side, two-way, three-way matching and invoice processing are definitely the number one use case. And then on treasury and tax, we're seeing a lot of like debt covenant monitoring and reporting. So this is part of the presentation. We have about 18 minutes left or 17 minutes left. I want to make sure that I answer any questions that anybody might have. Otherwise, I'm going to also jump into a demo. But for now, does anybody have any questions? There's a little Q&A button. If you have any questions, please submit it to in the Q&A tab right now. Okay, we have no questions. So let me jump into a quick demo then. All right, I hope everybody still sees my screen. So this is Klarity. And so Klarity is basically a way how to automate document-centric workflows for accounting and compliance teams. What you're looking at here is a dashboard. So this is the first thing that anybody sees after you log in. And every single one of these rows is what we call a deal. Deal can be one document, it can be multiple documents, but it's basically a transaction, and all the documents and all the data and all the like workflow steps that are related to it. Typically, the way the data gets in here is through an integration with another system. Salesforce, NetSuite, Coupa, Oracle, SAP, whatever that might be, but basically bringing the data automatically, the data and the documents automatically into the system. I'll pick one of these. There's a lot of reporting functionality, and so I'll get back to it, but I want to show the core functionality here. So I have this deal, I have an order form, I have a purchase order, I have a master agreement. So this is on the revenue side. And then I have a checklist set up as 5 steps of RevRec and order management use case as well. And the way Klarity works, and the reason why we're able to solve so many of these different workflows that I highlighted, is because the checklist is configurable. The checklist consists of 5 types of fields. So we have what we call extraction fields, and this is where the secret sauce are, like, which is the most important part of our system. The ability to understand document to the same degree as a human, and then identify and structure the data out of it. So we can extract simple things like customer names, billing addresses, payment terms, but also the ability to identify non-standard billing terms, the ability to take a table out of a PDF and structure it in columns and rows. So I can do something like, this. And this is all structured data coming out of a PDF. We can identify all kinds of pieces of language. We call this free text. So, here's an auto renewal, here's a price cap, here are retroactive true-ups, all of these different things. And so the system reads and understands the document, irrespective of how the document is phrased, irrespective of how it's templated. Has it been negotiated? Has it been expressed? Is it a purchase order that you received from a third party? The system is able to deal with that. Then we have other types of fields as well. So we have what we call integration fields, where we're bringing data from another system. In this case, this is Salesforce data. We can perform matching or reconciliations on a field basis. So for example, here, what I'm doing is the system is extracting an order form amount, so the total amount from the order form, and it's bringing the same data point from Salesforce CPQ. And it's basically flagging, hey, there's a mismatch. Somebody made a mistake in CPQ. And so instead of me just like blindly using this data in my NetSuite to actually report my revenue, the system is able to flag any incorrect items. This is the same for payment terms. So the system is picking up payment terms in the order form, picking up payment terms in the purchase order from Salesforce, and performing a three-way match. And you'll notice that the payment terms looks very different here. The system is still like normalizing all of the data. So that's when it comes to that's when it comes to kind of matching fields. We can also perform a fuzzy match. So this is most commonly used for entity names, like legal names of entities, and addresses built to ship to addresses. So the system is doing here, it's picking up a billing address from the order, and it's bringing the same data point from Salesforce. And you'll notice that it's the same address, 9 Garcia Gardens Street, 240 Steventown, Maryland, but they're phrased differently, they're structured differently. So I have Maryland, I have MD, I have some commas that I don't have in the other one. There's some OCR issues. This says ST instead of street, like all these different things. And the system is still able to match that substantively because it's the same address, just different phrasing. And then finally, we have what we call calculation fields. So I already mentioned that we have a price cap. So the system identify, hey, here's a price cap. It can also extract the actual percentage, right? So in this case, it's 5% per year. It extracted that. It already knows the fact that this is a 230,000 pound order, and then it can automatically calculate the extra revenue upon renewal that you're getting here, which in this case is 11,700 pounds, and then it can calculate total revenue upon renewal as well. And so it can automatically perform all these calculations as part of the process. And then at the highest level, what the system really does is it's dividing transactions that need human attention, and it assigns those through this workflow. We can have 1 level of review, 10 levels of review, whatever that might be, from transactions that don't require that are all okay. And those get sent automatically to autocomplete, and they either stay there or they get synced back into a system, either Salesforce or downstream. So that's kind of how the system works at its core. Does anybody have any questions here? Any Q&A that I can help with? Apologies, doing a lot of talking. And then I guess this is the most exciting thing. So this is what we're calling this AI analysis. So anybody can open this tab, and let me just refresh this so I can walk you through this from the start. So I have this AI analysis button, and this is basically allowing me to perform any kinds of search, reporting, data transformation query at scale at all of my data. So what I can do here is I can do things like, is there a column called, and we were looking at total revenue upon renewal. And so I can ask the systems like locate certain types of data that I have here. And I have everything here from a systems perspective, right? So I have all my Salesforce data or my Coupa data or all my NetSuite data that I need, but I also have all of my document data that I've extracted. And so I'm using this specific calculation that I just showed to work with, right? And the system was able to tell me, yeah, there's a column in the data set called total revenue upon renewal. And so I can say, list all values in that column. And what this is doing is it's writing custom Python scripts on the fly to do all this like data querying, data transformation, kind of like projects here. Oh, yep, Q&A. Oh, thank you, Scott. I appreciate the kudos. And so what the system did here is, okay, I have all of these values, and you'll notice that there's no standardization here, right? And there are all these like, random symbols, and the system even tells me that, right? There's a missing value, some entries have non-SCI characters, and so on. And so I can actually work with this data set directly. So I can say, okay, normalize all values and list them again. And so what this is going to do again, it's going to write a bunch of Python scripts, custom Python scripts. I don't need to tell it how to standardize it. I don't need to tell it it's like, oh, convert everything into dollars, or make sure that you retain a specific currency formatting. I don't need to give it any more context. It's all already embedded in the system. And so I can just give these like very kind of like almost bark, like very high level orders at the system, and the system is able to deal with them and give me a custom response to my custom query. And it can even tell me, it's like, okay, I've converted this from euros into dollars, converted this from GBP. So it did auto conversion for me as well. And so now I have a normalized data set. And then I can do an outlier analysis. I can say, are there any outliers? And again, I'm not saying, hey, I define an outlier as something, with a certain level of standard deviation or anything like that. I just say, are there any outliers? And so this is enabling every single person on my team, even if they don't have any specific like quantitative background, or if they don't know how to write code, or they don't have like super advanced Excel skills, to basically work with the data, right? And it tells me, okay, there's one data point, it's $4 billion, right? So in my total revenue upon renewal. So, which is unfortunately, not true. I don't have any customers that are paying us $4 billion a year, at least not today. And it's even telling me why it's like, okay, it's much greater than 1.5 times. So it exercised judgment in figuring out like what is the standard deviation effectively, or what am I looking for? And then I can say, okay, remove the outlier and generate a quartile analysis. And so I can give it two instructions at the same time as well, or multiple different instructions. I can say, do this, and that. And it only depends on my level of comfort of, okay, do I need to see the data? Do I need to see the response before I give the next instruction, right? So here I was giving one instruction at a time. So I wanted to see like, okay, give me a sense for the data. And then I saw, it's like, oh, okay, there are all these problems. Okay, can you normalize the data? And then I have then it performed a quartile analysis for me. And then, finally I can do something like, generate a pie chart showing this analysis. And by the way, we're like 4 minutes into this entire analysis, right? So this entire thing that like, would take a lot of spreadsheet work and a lot of like custom formulas, like, okay, convert, figure out how to convert GBP into USD. What is the the current rate of exchange, and like how do I define an outlier? Like, should it be at 1.5, or should it be for interquartile analysis, or should it be 2.x? And then I go all the way to a pie chart in 5 minutes. I even have a narration, tells me, okay, first quartile is 26.3%. It just gives me all of this analysis, gives me the chart, gives me everything that I need. And I can do this on this extremely rich data set that I already have, because I have all of the document data, I have all of the system data, I have all of my calculations, I have my matching or reconciliation data. So I have that rich data set. And then on top of that, I can perform all this analysis in real time without having to have my BI team or anybody like that spending a lot of time. I know that we have 4 minutes left. And I noticed that nobody dropped off after I started showing this. So I'll take it as people are pretty interested in this. But if anybody has any last minute questions, please submit them now. If not, then thank you so much for your time, and let us know if we can be of any help. Okay, it doesn't look like there are any questions. So thank you so much. Have a great day and happy holidays, everyone.